Good day guys. Today, pag-aaralan natin kung paano mag-perform ng material balances for single unit non-reactive processes. Okay? Kasi merong mga process na reactive. So, in some other lectures, we will cover that. Ang focus lang natin ngayon ay yung mga non-reactive processes, and we will first discuss yung mga single unit physical processes lamang. Later on, we will also discuss yung mga multiple unit processes. Okay? So, here are the general steps in solving material balances, and this is generally applicable sa mga physical processes. Okay? So, number one, you should draw a clear process flow diagram showing all relevant information. So, yung process flow diagram, it could be using a, let's say, a rectangle or a block. Okay? And in that diagram, okay, that symbolizes the process, let's say a drying process or an evaporation process, isusulat mo doon, okay, you can use arrows to state or to draw yung mga relevant information like gaano kadaming feed ang pumapasok, gaano kadaming product ang lumalabas. You can write also the stream composition if you have that, okay? So that is how you will draw a process flow diagram or a flow chart. Number two, you should select a unit or a set of units and state it clearly. Okay. So if you're using an MKS system or a metric system of units, you should be consistent. Okay. For example, may mga problem kasi na, let's say, kilogram ang mass flow rate doon sa feed, pero pagdating sa product, ang pinapahanap naman ay pounds, for example. We should select only one system of units. So if you're using the English system, for example, you should be only using the English system for the entire calculation. Number three, select a basis for the calculation and state it clearly. So ano yung basis? So yung basis is isang assumption, okay? And it's the flow rate of one stream or component, okay? So for example, merong binigay na mass or flow, okay? It's probably a good basis to use. So halimbawa, sa isang process mo ang feed, sinasabi doon 100 kilogram. So that will be your basis. Okay? Sometimes walang given naman na amount ng feed, for example, or ng amount of product, for example. So sometimes, or many times, they are unknowns. So you can probably assume a value for the basis. How do you do that? You have to select the stream kung saan mayroon siyang pinakamarami or most known yung composition. So let's say, ang feed, meron kang percent of A, percent of B, percent of C component. So malamang, it's a good basis na mag-assume ka ng amount ni feed. And usually, we use the value of 100, maybe 100 kilograms or 100 pounds, depending on what set of units have you selected. Okay? Sometimes naman, ang nakalagay na stream value or amount ay naka-flow rate siya, with whether mass flow rate or volumetric flow rate. Okay? So in that case, you can also use time, okay, as the basis for the operations. For example, sa feed natin, ang nilalagay natin dun sa unit ay, let's have, for example, 150 kilogram per hour. So 1 hour is probably a good basis for our calculation. So that, in all of your calculations, so if you have determined the value of the other streams like product or waste, okay, you will get the value later on, and then your final answer will be per hour also. Okay. So number four, you have to state all assumptions applied to the problem. Okay. So sometimes the assumptions are quite obvious na hindi mo naman na kailangang ilagay. For example, sa ating exercises later on in this video, we will be focusing on non-reactive processes and we will be focusing on single unit processes, right? So it's probably good to assume na steady state yung process, all right? In fact, for most of our video lectures, we will assume a steady state process for all our examples, okay? Number five, identify which components of the system, if any, are involved in reaction. So gaya ng sinabi ko kanina, generally, itong steps na to ay ginagamit sa mga material balances for non-reactive processes, right? But if there are any reactions, okay, you have to, number one, indicate the stoichiometry of the reaction. What I mean is that you have to write the balanced chemical reaction, okay, or chemical equation. It should be balanced, of course. And you have to identify which components are reacting. So may mga components kasi na hindi naman pampagulo really, but they are there, let's say nitrogen or maybe some catalysts. So they are not participating in the reaction, but they are there. So you have to account for these values. Okay? You have to identify the tie component. So anong ibig sabihin ng tie component? Yung tie component, okay? So, di ba, alam natin na yung flow for any component, okay, it will be in the same ratio to the flow of any other component as the ratio of the concentrations of the two components. So if one component passes unchanged through a process unit, it can be used to tie the inlet and outlet compositions. So yung technique na to, it's particularly useful kapag you're handling calculations maybe involving combustion or any other processes na mayroong material na hindi change, no? It remains unchanged throughout the process. Okay? And you can use that, okay, para ma-determine yung streams or yung flow, okay, or flow rate of the other streams. Okay? Kasi alam mo naman na yung component doon na tie. Okay? So it will help you in your calculations. Number 6, set up equations and calculate. So once you have set up your equations, normally there are just algebraic equations. Okay, sometimes you have to solve equations simultaneously. So 2 equations, 2 unknowns, 3 equations, 3 unknowns. And number 7, you have to finalize and answer specific questions asked from the problem. So for example, ang tinatanong pala sa problem ay percent composition. Okay? Ang mga nakuha mong value so far, let's say sa product, the product contains A, B, and C. Okay? And in your calculation, you have calculated the mass of A, the mass of B, and the mass of C, for example. Okay? Hindi nagtatapos doon. Yun pala, ang pinapahanap sa problem ay percent composition. So you have to get the total of those components, their amounts, right? And then you have to get the percentage of each component. So something like that. Okay? And there are other specific questions na pwedeng itanong doon sa problem. Okay? So let's have our first example. So the first example that we're going to discuss is yung drying process. Okay? So ano tong drying? Si drying, it's the removal of relatively small amount of water or other liquids from the solid material, but kadalasan water siya. Okay? And the word is that the removal should be, okay, or yung amount ng water should be relatively small. All right? Bakit tayo nagpe-perform ng drying? Usually si drying, okay, kapag bioprocess ang pinag-uusapan natin, it's often the last step in downstream processing for recovery of solid products, let's say cells, okay, from fermentation, no? So halimbawa, nagkaroon ng fermentation, you have to harvest the products or cells, the cells themselves or the biomass is the product, for example. So anong usually ginagawa? Sometimes you do filtration, and after filtration, you have to perform drying pa. Okay, so drying is an important downstream process. Okay, in other kinds of processes, not necessarily bioprocesses, ang drying mahalaga siya because it is a preservation technique, right? Microorganisms, they tend to thrive in wet environments. So kapag naliitan natin or nalimitahan natin yung amount of water dun sa product, then malilimitahan din natin yung growth ng microorganisms. And in that case, you have preserved your product. Okay? And also, yung drying, it renders the product suitable for packaging, di ba? It renders the product suitable for storage, and it will reduce the cost of transport kasi nga na wala na siya ng kaunting moisture. So, ayun, nabawasan mo ng kahit papano yung cost of transport natin. Okay? So, normally, ang drying ay ginagawa siya using hot air drying na nakikita natin dito sa diagram. So you have your dryer. So ito yung tinatawag natin, or is an example of a flow chart, okay? Or a process flow diagram. So sa drying, specifically for hot air drying, okay, you have your wet material here, okay? So you have your wet material, and we use the symbol F for feed. And after the drying process, okay, of course, you will expect na meron kang product na dry material, and we will use the symbol P for the product, okay? How was it achieved? So you're using dry air to do that. So you have a dry air, and after some time, you will have now a humid air, okay, because drying happened. Now, yung solids, okay, doon sa loob ng wet material natin, okay, nahati siya, or the components rather of the wet material are the following. So we have number one, of course, yung moisture. So si moisture, it's in the form of water, of course, right? Whilst the other component in your wet material is what we call your bone dry material. So bone dry material. Okay, or BDM. So ito yung sinasabi natin kaninang tie component. So the BDM or bone dry material can be used as a tie component because yung bone dry material na yan, presumably, okay, it's unchanged during the drying process. Okay, so presumably hindi siya nasisira and all that. Okay, so whatever the amount of bone dry material in your F should be the same as the amount of bone dry material in your P. So ang nagbabago lang yung water. Kasi nga yung water, matatanggal siya here. Okay? Now, there are some cases kung saan yung mga materials natin are heat sensitive, and also sometimes they are oxygen sensitive. And a good example is yung ating pharmaceuticals. Okay? So in that case, normally hindi nagwo-work si hot air drying. So we usually perform for them yung tinatawag nating vacuum drying, kung saan we remove the moisture or yung water under vacuum. Okay? So ginagamit nga siya sa pharmaceutical industries. Sometimes also we use what we call the freeze drying technique. Okay, so freeze drying is also called lyophilization or cryodesiccation. Okay, so ang ginagawa kay freeze drying, so you freeze the material first, let's say the product, and then it will undergo sublimation kapag nilagay mo natin siya sa vacuum. Okay, tapos you apply a little heat to accelerate the sublimation. Okay, and then after that, magko-condense na. Okay, magko-condense yung ating material, okay, yung water rather, and in that case, it will remove the vaporized solvent. Okay, so yung water, which is ice in that case, okay, because freeze drying nga tayo, that will be removed by sublimation. So ginagamit tong freeze drying na ito sa also in pharmaceutical products and some biological products like bacteria, yeast, and even surgical transplants. Okay, because these materials are also heat sensitive, so you have to avoid high temperature. You have to maintain their, let's say, their integrity or their shape, and usually if you have high temperature, madadamage yung mga materials na to. So you have to perform either vacuum drying or freeze drying. Okay. So let's solve a problem involving the drying process. So I have here, so we have a dryer designed to evaporate a constant amount of water every hour. When the dryer runs using 5 tons of feed per hour, a product weighing 3.4 tons and containing 11.6% water was produced. If the product must not contain more than 4% water, calculate the amount of feed required and the amount of product formed. So kung mapapansin nyo sa problem na to, there are actually two drying cases, all right? Kasi Ang requirement dito sa ating dryer is that constant dapat yung amount ni water, alright, na natatanggal. Okay, so here we have first yung ating 5 tons of feed, okay, per hour. Tapos after the drying, 3.4 tons daw yung product na nakuha. And that product contains 11.6% water. In the second case, ang kailangan natin, yung product daw, 4% lang or less. Okay? Yung water content niya. So kapag yan yung kailangan natin mangyari, ano dapat yung amount, proper amount ni feed doon sa ating dryer? And let's calculate also the amount of product form. Okay? So let's answer this one. Okay, so first let's draw. So as a first step, let's draw basically yung ating basic process flow diagram. So it's basically a dryer, right? So we have here, I'll be using like a rectangle. So this is our dryer. Okay, and then meron daw feed, which is 5 tons per hour. Okay, 5 tons per hour. And yung product is ilan daw? In the initial case, it produced 3.4 tons per hour. Okay? At nalaman din natin, according to the problem, 11.6% daw yung water. So doon pa lang, you will be able to solve how much solids, okay, or yung tinatawag nating BDM, ang naroon sa product. So just subtract it from 100%, therefore 88.4% ang solids. Okay? Ayan. Now the feed F contains also water and solid. All right? Yung kanilang composition ng water and solids, okay, in terms of percentage, malamang iba. Pero ang alam natin dito, kung gaano man karami yung solids dun sa product, which we can calculate that, right? Because we know the percentage, ganoon din kadami yung solid doon sa feed natin. Okay? So ilagay ko lang din sa feed yung kanyang composition. It's also what? Water and solids. Okay? And of course, meron ka ditong matatanggal because it's a drying process na matatanggal na water. Okay? So in the form of course, H2O. So water, W. Okay, so ano ba ang required dito sa problem? So the required, okay, is number 1, F, and number 2, P. Okay? So F and P, the feed and the product, their amounts are required. Pero teka, di ba meron na tayong amount ni feed at ni product? So actually, ang sabi sa problem, ano daw yung F tsaka yung P? Alright, if P has what? 4% water. Okay, di ba yun yung requirement sa ating problem? Dapat yung product hindi lalampas ng 4% water. So if that's the case, ano dapat yung F? Ano yung amount ni F per hour? Ano yung amount ni P per hour? Okay? So the requirement here, or the dryer, is designed to remove constant amount of water every time. So in the first drying case, you have this amount of water removed. In the other cases, dapat ganoon din kadami yung na-remove na water. So yun yung isa pang criterion. Okay? So let's solve. So what will be our basis? So meron ka kasing mass flow rate, which is tons per hour. So we have for feed, it's 5 tons per hour. For the product, it's 3.4 tons per hour. So it's probably a good basis to have na gamitin natin ng 1 hour. Okay, or we can say 1 hour operation as our basis. So sinasabi lang natin dito, since may 1 hour operation tayo na basis, kasi you can actually use 24 hours or 1 day or even 1 month. Kaso nga lang, mababago yung value ni F and P. So that's why you stick to 1 hour operation. So that simply means na in our succeeding calculations, so that have to put per hour anymore kasi nag-basis tayo ng 1 hour. So ang amount ni F natin therefore ay 5 tons. Okay? And ang amount ni P natin ay 3.4 tons in the first drying case. All right? Now, you would start with the overall material balance. How would it look like? So remember lang, I will write this in the succeeding lectures, but diba remember, ang ating overall material balance ay ito. Okay, diba? We have input, okay, plus generation minus output minus consumption equals accumulation. Tama ba? Okay, so this is our general overall material balance. This is the general equation. But since okay, wala namang reaction dito, so wala tayong generation, wala tayong consumption, at we are assuming here na ang process natin ay steady state, so there will also be no accumulation. So you will end up with the statement that input, okay, is equal to output. All right. So yan yung ating general working equation for non-reactive processes, steady state. Okay. So what will be the overall material balance equation for this specific example that we have? So overall material balance. Okay. So if you are going to take a look at the process flow diagram, so overall, ano yung nilalagay natin, pinapasok natin, ano yung nare-remove natin. So in symbols, okay, we have F as entering, and then sa outlet naman natin, it's W, okay, plus P, or yung water plus product. And you can actually substitute already yung value na meron tayo. So for F, it's 5 tons, right? Equals W plus, well, for P, we also have a value or an amount. So that's 3.4. So simply, makakalculate agad natin yung amount ni water, which is 1.6 tons. Okay? Now, anong susunod? So after doing the overall material balance, we could probably do the component balances. Component balances. Okay, so kanina overall, diba? But for the component balances, you will consider each component, pwedeng solid, pwedeng water. So there are only 2 components in the process, solid tsaka water. So you can do solid balance or you can do water balance. Normally, sa ganyang pagkakataon or sa ganyang case, pwedeng isang component balance lang, alright? But sometimes, in other problems, kailangan mong kumpletuhin lahat ng component balances. So let's have the solid balance. Solid balance. Okay, so for the solids, okay, we can say that the solids in our feed, okay, is equal to what? The solid in W plus solid in the product. Okay, so you just have to take a look at our process flow rate, our process flow diagram. However, there are no solids, right, in water, okay, or in W. So ang matitira na lang therefore is what? you'll have solid in F, okay, equals solid in P. But what is solid in P? Solid in P is actually 88.4% of P, right? Solid in P is 0.884 or 88.4% of P. But what is P? P is 3.4 tons. Okay? So therefore, yung solids in F, we can compute it right away. So solid in F is, if you do this calculation, 0.884 times 3.4, you will get 3.0. Okay? Now, since meron ka ng solid in F, okay, ano pang pwede nating malaman? Hindi ba we know that the feed is 5 tons? So if you go back to the analysis of F, diba si F, okay, let's put it right here. Si F, meron siyang water. Okay. At meron siyang solid. But si solid, alam natin na, na-compute na natin na 3 na siya, right? 3 tons. So therefore, by subtraction, because F is 5 tons, right? By subtraction, we can say, or we can calculate, we can compute that water is 2 tons. Okay, therefore 2 tons. Okay, you can put it mathematically if you want in a form of an equation. Okay, so water in F, yan yung 2 tons. Now let's probably state this composition in terms of percentage. So we can probably write something like percent water in F, diba? It's 2 over 5 tons times 100. So ilan yan? That's 40%. Okay, now the percent solid in F is simply what? 3 over 5, or you can just subtract this 40% here from 100%. So we can do both, or we can do just the first one. That's 60%. So a total of 100%. Okay, now kanina nag-perform tayo ng solids balance, right? You can actually perform water balance as well to check, right? So let's just do that to check. Okay, water balance. So simply water in F, okay? Just look at the flow diagram. Okay, F equals P plus W, but the composition in terms of water, water in F equals water in W plus water in P. Okay, so water in F, we have found it to be 2, right? Water in W is W, okay, and that W is 1.6 tons, which we have calculated a while ago. Okay, plus water in P. So paano yung water in P? Diba yun yung sasabi nating 11.6% of P. So 11.6% of P. The value of P is 3.4. So if you're going to check this, okay, the left-hand side will be equal to the right-hand side. Okay. Now, what we have done so far is, number one, to perform the overall material balance, or to write the overall material balance. We did, in doing that, we were able to calculate right away yung missing or yung unknown value natin na stream, which is water or W. Okay. when doing component balances naman, what we were able to achieve is that we were able to find out, okay, kung gaano kadami yung solid sa F, and because of that, we were able to find out kung gaano kadami yung solid sa, or yung water sa F. All right, and we were able to get the composition of F. Okay? Now, hindi pa dyan nagtatapos. Kasi remember that the requirement is that ano daw yung F and P if the P, okay, has 4% water. So, hindi dapat lalagpas ng 4% ang water sa P. Eh, kanina kasi 11.6 yung water natin. So, therefore, we can create a new flow chart, okay, or diagram. So, still dryer. Okay, so this is case 2 already. Case 2. So it's the same thing. You have an entering feed, okay, or an inlet, and then my P, okay, that's water. In this case, we don't know F and P, but what we know is W, which is 1.6 tons, okay? 1.6 tons. Kasi, according to the problem, it's stated na dapat it should remove a constant amount of water for any drying case for this particular equipment. Constant lang yung nare-remove niyang water. Okay? So, yung feed natin, well, kung ano yung feed natin kanina, yung amount niya, iba na dito sa case 2. What did not change, however, is yung composition ng feed. So, di ba nakuha na natin yung composition ni feed, which is 40-60. So, feed is 40% water. Okay, we know that already from our case 1 calculation, and 60% solid. Okay, and yung product natin, sabi sa problem nga, dapat 4% lang yung water at therefore 96% yung solid. Okay, so if we're going to do the overall material balance, it's F equals W plus P. It's probably good to substitute what we know already, which is only yung W, no? W, oh, sorry. So let me list that. W is what? 1.6. So 1.6 plus P. So that is our equation 1. Okay, now let's perform component balance. Maybe we'll have solid balance. Okay, you can use water balance if you want. So for solid balance, diba, solid in F equals solid in W plus solid in P. Okay? But yung solid in W, wala yan. W is purely water, right? So solid in F, it's 0.6 of F, right? We don't know F, but we know the composition of that, which is 60% solid. So 0.6 F equals solid in P. So solid in P, we know that also. I mean, it's stated here na 96% ang solid dun sa P. So that's 0.96 P. Okay, so this is now your equation 2. So you have here 2 equations and 2 unknowns. Okay. So all you have to do is solve these equations simultaneously. Pwedeng substitution, or pwedeng you can use your calculators. Okay. And therefore, if you're going to solve, okay, solving, and I will not show how it is solved, but solving equations 1 and 2, you will get the following. F equals 4.27 tons, and P is 2.67 tons. Okay. You can use also yung water balance natin to check. All right. So probably let's do that, no? So to check, diba, water balance. So water in F equals water in W, which is just W, right? Plus water in P. So water in F, that's 40%, right? 0.4 of F. So yung F nakuha natin is 4.27 tons. Mag-equal pa siya dun sa right-hand side. So water in W is 1.6. Plus water in P, sabi natin, 40% yung water sa P. Sorry, 4%. So that's 0.04 times the amount of P is 2.67. And it turns out na the right-hand side is equal to the left-hand side. So therefore, tama yung ating sagot. So what should be our final answer? So ang hinahanap, okay, sa ating problem is yung F tsaka si P. And ito na yun, right? These two values that we obtained. So F is 4.27 tons. Pero since nag-basis tayo ng 1 hour operation, so you can put here per hour. And P is 2.67 tons per hour. So these are your final answer. So of course, if you made or if you had a different basis, let's say 2-hour operation or 24-hour operation, mag-iiba yung value ni F tsaka ni P. Pero kapag ginawa mong per hour, okay, it will give you the same final answer na 4.27 tons per hour and 2.67 tons per hour. So in the next video, we will discuss another example, which is evaporation.